Hey all you cool cats and kittens. For this video we're going to be doing number 13.49 from the book, and the question is they give us the density of two different substances, right, two different liquids, and they say that we mix 22.5 milliliters of methanol and 98 milliliters of acetonitrile. They give us the densities of these two substances. So then they want to know the mole fraction. Remember, mole fraction is represented by that giant chi sign, right? It's a Greek X. So what is the mole fraction of methanol in the solution? So in order to do mole fraction, if you guys recall, mole fraction is moles of the component divided by total mole. So it's great and all that we get these volumes, but we need to turn the volumes into grams using the densities, and then using the molar masses, we can turn them into moles. So we're going to have to do that big scratch work on the side. So how do we get the molar mass of acetonitrile? 2 carbons plus 3 hydrogens plus 1 nitrogen. How do we get the molar mass of methanol? 1 carbon plus 4 hydrogens plus 1 oxygen, right? So if we went ahead and did that kind of math, we would find that acetonitrile is 41.05 gram per mole, and we would find that methanol is 32.04 grams per mole, right? So these are the numbers that we're going to have to use in order to find a number of moles. So let's go ahead and do it for methanol first. So we are given 22.5 milliliters of methanol. Put it over 1, and then you multiply it by the density. So it is actually 0.791 grams for every 1 milliliter. And then we're going to turn that grams into moles using the molar mass. So it's 32.04 grams for every 1 mole. So I'm going to do a little calculation here on the side. You guys should always make sure that you do it with me to make sure that you are comfortable with how to enter these things in your calculator. Looks like we have 0.555. 0.555 moles of methanol. That's one little bit, right? For the second one, we're going to start off with 98.7 milliliters. Looks like it's 0.786 grams for every 1 milliliter. And the molar mass is 41.05. 1 mole. Okay. So it looks like for that bad boy, 0.786, divide that by 41.05, we get 1.88, okay, so 1.890. How about that? Moles of acetonitrile. So if we were to do this setup here, our magical little equation, we're going to have to put, for mole fraction of methanol, we would put the mole fraction of methanol as 0.555 moles divided by whatever 0.555 plus 1.890. You could do this in one step in your calculator, or you could do it in a couple steps. So 0.555 divided by parentheses 0.555 plus 1.890. We get 0.226, so 69, so 0.227. Now what are the units? It's mole on the top and mole on the bottom, right? So these guys are going to cancel out. So this is my final answer, 0.227 is the mole fraction of methanol. What if I wanted the mole fraction of acetonitrile? You just take 1 minus this. Remember, mole fractions have to total up to 1. The second part of it asks for the molality of the solution. So you notice the question doesn't identify what is the solute and what is the solvent. So this, in a situation where we're mixing liquids, the solute is the item that is in the smallest volume. So we're going to have to put, for molality, if you recall, it's going to be moles of the solute divided by kilograms of the solvent. So in this case, it's going to be moles of methanol divided by kilograms of acetonitrile. We already solved for moles of methanol, so we have that guy already. Let's find kilograms of acetonitrile, right? We have this from part A. Let's do this from part B. So we started off with 98.7 milliliters of acetonitrile. We know the density is 0.786 grams per milliliter. And then what else we know about kilograms is that there are 1,000 tiny little grams in one big kilogram. So type this little guy off to the side, 98.7 times 0.786. Divide this by 1,000. You get 0.0776 kilograms. So our final step, so this is the bottom, this is the top part, right? So all we have to do is do our final plug and chug here. So moles of methanol is 0.555 divided by 0.0776 kilogram. If I were to type that out, I get 7.15. Lowercase m. And that is my final answer. All right, guys. Hope this helped out.